All right, so what we're talking about here today is slope, and we're going to first start by looking at parallel and perpendicular lines as we continue on learning about this. So first, what we have here in this is we have two lines, line A and line B, and we're going to want to write them in slope-intercept form. So in order to do that, we need to actually figure out what the slope of each line is. And remember, slope is rise over run. So this is our how much do we change in the y direction or how much we change in the x direction. And so if I look at line A, I see that I have a rise here. If I go from 1 point on the line, I can rise up 2 there and then do a run over to get back on the line of 1. So for line A, right, line A, I have a slope equal to 2 over 1, which is just 2. And then what I can do is put this into y equals mx plus b form. All right, mx plus b, where while looking at this, I already know m, that's 2. And then I just need to figure out b. Well, b is the y-intercept, and if I look here, that's my y-intercept, and it's at 1, 2, so this would be 2x plus 2 right there. And so there's my equation for line B. If I go over to do the next line, I can again do this rise, which I get a rise of 2, and then I have a run of 1 in order to get back over on the line. So I have a 2 and a 1 again. So for line B, I have a slope equal to 2 over 1, which is 2. And then this gives me y equals, again, mx, so 2x. But this time my b is not that positive 2. It's actually down here at negative 2. So I'd have 2x minus 2 there for that one. And so if you look at our two equations, what you would notice is for these two parallel lines, we have the same slope right there, which we calculated for both, which was equal to 2. So what this tells us is that parallel lines have the same slope. All right? The same slope. So any two parallel lines will have the same slope. Okay? Now let's take a look at this next one. It tells us to write an equation for line A and line B. So again, if we look at line A, it's the same as our previous line B was. So for line A, we have a rise of 2 and a run of 1. So we still have that slope of 2. And so we end up with y equals 2x, and then we still have that same y-intercept, so we still have that, oops, not plus 2, that negative 2 there, where it's hitting down at negative, oh, actually it's negative 3 now. Negative 3 down here, sorry. 1, 2, 3, it's 3 down. So we're at negative 3. And then for line B, all right, here we look at our slope and we've got a rise of 1, and then our run goes back in the negative direction, negative 2. So our slope here is going to be 1 divided by negative 2, rise over run, which means this is just negative 1/2. So when we write this equation, we have y equals negative 1/2, and then the x, and then we have the same exact y-intercept right there, which is the minus 3. So if we look at these two equations and we compare the slopes, we have a slope of 2, and here we have a slope of negative 1/2. Evidently, what this is telling us, and what turns out to be true, is that perpendicular lines have negative reciprocals as slopes. So if the slope is 2, then the other line has a slope of -1/2. If the one of them you're given is a slope of 1/2, then the negative reciprocal of that would be 2. So they are negative reciprocals of each other as far as their slopes. All right, so let me take a quick second and see if there are any questions. All right, so let's take a look here at this example where we can go ahead and putting this into use. So here we're going to use the given condition to write an equation for the line in slope-intercept form. All right, so what we've got here is they're telling us that it passes through this point here, but is also parallel to this point, or this line. Well, if it's parallel to this line over here, that means it must have the same slope. So we know immediately that we have a slope equal to 2, just by picking it off of the line that it's parallel to. We now know a point that it goes through. Thankfully, we know our point slope form here, where we can do y minus y1 equals m times x minus x1. And so I have y1 right here and x1 right there, and I just have to plug them in. So it becomes y minus -5 equals our slope of 2 times x minus -1. And just to color coordinate that for you, this -1 is that -1, this -5 is that -5, and then this, let's see if I can get a different color here. Let's go with green. This 2 right here is from the slope of 2, which came from that 2 right there. All right, and so that's where I got all those numbers from. And then I just have to put this into slope-intercept form. So this becomes y plus 5, and then I can distribute this. This is minus -1, so it becomes plus 1 like that. And then that'll become 2x 2 by distributing that through. And then I just have to subtract 5 from both sides, and this becomes 2x. 2 minus 5 is -3. And there we go. We have our equation in slope-intercept form. And again, it has that same slope of 2, but a different y-intercept than that one. Okay? And then if we take a look at this next one, do one more here just to kind of get you started. Here, they're telling us that it's passing through a point, but they're giving us a line that's perpendicular, not parallel this time. So just to start you off on this before I let you try it, we look here and we see we have a slope of 1/3. That means the slope for our new line has to be negative of the reciprocal of that. So -3. The reciprocal of 1/3 is 3, and then we put the negative of it. So the slope for the line we're looking for here is 3. So what I want you to do is go ahead and try and finish up that problem right there and see if you can get an equation in slope-intercept form that goes through that point and is also perpendicular to the other line.